The SBS Schmidt balance systems SB-2000 and SB-2000-P are a range of dual-plane manual balancing systems designed for accurate dynamic balancing of rotating machinery. In this video, SBS demonstrate the SB-2000-P, the portable version of the unit. The SB-2000-P is a dedicated two-plane balancer supplied with everything that is required to carry out on-site balancing, including the control unit, two vibration sensors, photoelectric speed sensor and tough ABS carry case. Pressing the wrench button once, make the general settings. Here we select vibration sensor 1 for a single plane balance. Vibration units in microns, peak to peak. Press the wrench button again for individual vibration sensor settings. For this demonstration, we have selected a 3-weight balancing solution as we're balancing a grinding wheel that has 3 weights on the flange. Angle orientation is important. In this example, the grinding wheel is rotating clockwise and the angular increments on the wheel flange are increasing in a clockwise manner. Therefore, we select equals 2. Pressing the wrench button again exits the settings. Let's look again at the angle orientation. Here we can see how the degrees on the index ring increase in a clockwise direction. The grinding wheel will also rotate in a clockwise direction. Therefore, the setting is equal to. The photoelectric speed sensor uses reflective tape to get a speed reading and should be mounted 30 to 100 mm away from the rotating body and be perpendicular. The vibration sensors are magnetically mounted and in this case are placed directly over the first set of spindle bearings. Firstly, check the initial unbalance of the grinding wheel by starting the spindle. The controller indicates that this is 24 microns peak to peak. Make a note of this figure and then stop the spindle. The balancing process is split into 3 phases: the zero phase, the test phase and the solution phase. Press the balance button to begin the balancing process. For the zero phase, place the weights at 0, 120 and 240 degrees. At these angles, the weights are having a null effect on each other. When you are happy the weights are at the correct angles, press next and start the spindle. As the weights are in the null position, we can see that the grinding wheel in its raw state is inducing 20 microns of vibration into the spindle. Press next when the readings stabilise and stop the spindle. Now the test phase. Position the weights at 0, 90 and 270 degrees. As we are using equal weights, it does not matter which weight goes in what position or whether the weights are mixed. Press Next and start the spindle. Note that the test run may make the vibration better or it may make the vibration worse, as well as changing the phase angle. When the readings stabilise, press Next and stop the spindle. Here we have the solution phase. Having carried out a zero run and a test run, the SB-2000-P will tell us at what angle to place the weights in order to achieve a final balancing solution. In this case 71, 144 and 359 degrees. Once we're happy the weights are in the right place, press Next, start the spindle and check the results. We can see that the spindle vibration has been reduced to around 0.4 microns. If we recall, our initial grinding wheel unbalance was inducing a spindle vibration of 24 microns, so a 60-fold decrease has been achieved. Always adhere to appropriate health and safety regulations when working with rotating machinery. Thanks for watching.